Good morning. Welcome to Talbot TV. This is your first challenge, Challenge 1 basketball drill, and this is Mr. Afflerback. Hey, the challenge for this week, or this first challenge, is going to be, I call this the basketball drill. So we're getting our robot, and we are going to touch 4 different lines, and these are marked on the floor. The first line's at 1 meter, the second line's at 2 meter, this third line is 3 and 4. So our robot's going to do something like this. Or your robot's going to do something like this. So go to 2 meters, go back, go to 3 meters and back, go to 4 meters and back. So that is going to be our challenge for challenge 1. But what does the pseudocode look like? Well, this time it's going to be, I believe it's going to be up to 8 steps. So let's see these and we'll see how this works. So the first 2 are going to be move forward to 1 meter, move backward 1 meter. Again, move forward 1 meter, move backward 1 meter. The next 2 are going to be move forward 2 meters, move backward 2 meters. The next 2 are going to be move forward 3 meters, move backward 3 meters. And the last one is going to be move forward, or last pair, I should say, are move forward 4 meters and move backward 4 meters. So here's some concepts I just want to go. They're not necessarily new. We've talked about these before, but I certainly want to make sure we review them since this is our first challenge. So we have something called a task main. This is a control structure. So it's going to have open brackets and close brackets. So, and their code that we need to run is going to be in the middle of those 2. We'll see some coding, a coding section a little bit later. But notice that task main is all lowercase. There is a space between the 2, which is kind of an oddity in computer programming. Then we have parentheses on the top right after task main, and then again the open curly brackets and the closed curly brackets around our code. Okay, the next new concept, again, we've seen this before, but let's review, is how do we set the motor power? Okay, so we're going to start off with our motor. And then we're going to have a square bracket. Remember, the motor is going to be an output from the cortex to the motors, so it is actually going to need to tell where it's going to. So in this case, we're going to look at the right motor, and we need square brackets to do that when we talk through the cortex. And we're going to close our square bracket, and then we have the equal sign, and 63 is going to be our speed this time. Or actually, I want to say speed yet. I want to say our power. Okay, and then since this is a simple command, we're going to have end this with a semicolon. Now, when we want to go straight, we want to have the right motor and the left motor both going in the same direction. So we're going to have a similar command for our left motor. So notice that I have the right motor and it's RIGHT all in lowercase, a capital M, OTOR. That's exactly the way it's written in our motors and sensors setup. All right, the next new concept is going to be simple commands. This is how we're going to do a set pause. Okay, we said we can pause by doing wait 1 msec, and in this case, this is going to have a parameter inside of it. So we're going to have a open parentheses 1850, and we'll see where that number comes from in a little bit. And we're going to close that with a semicolon. Again, this is a simple command. And simple commands, as the controls, know when to go to the next line when it sees a semicolon. And of course, what's going to be helpful for us is if we know what's going on. So I like to put comments on things. So in this case, we have pause of 1.85 seconds. Again, we'll see where this 1850 milliseconds comes from in a little bit. All right, so we've got to calculate the pause time. Now that's the number that we just looked at, that 1850. We have to figure out where does that come from. So a couple things we need to know. First of all, we need to know how far the robot travels in one rotation of the wheel. So we could measure that. So we could start our wheel, roll it. Okay, I have the yellow triangle there to mark a point, and it's going to end there. So this distance that we have, the distance that traveled in one revolution, is actually going to be equal to the circumference of the wheel. sounds like it should work. So let's go and look at how do we figure out the circumference so we can actually go get one of our values that we need to know. All right, so here's our wheel. Our circumference, the way to calculate circumference is pi d. Sometimes we see it as 2 pi r, but we know that diameter is 2 times radius. And so we could just keep it, since we're measuring the diameter, we might as well just keep it that way. So we have the circumference is equal to pi d. So we could get a ruler out and measure the wheel diameter, and we'll find out that it's 10.3 centimeters. And in this class, and most science classes, we actually will use the metric system. So we're going to keep with that. And we need to convert everything into meters. So that's 10.3 centimeters divided by 100, which is going to be how many centimeters are in a meter, is going to give us 0.103 meters. So we're going to need that number a little bit later. Okay, so here's our circumference. Actually, here's where we're going to need it. So here's our diameter. So pi times the diameter, and we actually get a circumference of 0.324 meters. So I have 3 decimal places here. I think it's okay to use 3 right now. So that's one thing that we've got. So now we have our circumference. So that's one of the 3 things that we need to figure out. All right, let's look and see how we get the next one. Okay, we have to realize or to figure out how fast the wheel is rotating. So here's our wheel and it's rotating. Okay, but how fast is it rotating? Well, that's actually has in science, we actually call that the angular velocity, and it's symbolized by a Greek letter called omega, and that's that little W that you see in parentheses right after the word angular velocity. So that's the symbol for angular velocity. Now, angular velocity is measured in revolutions per minute. So that's one of the things that we've got to keep in mind. Now, we're going to probably change the revolutions per minute in a second, but for now, let's look at what we've got. All right, so how do we get this? To be honest, we actually have this information already. We just got to get it into the right form. So we're going to go back to our actual curve that we came up with, that my Robot 2 kids came up with, and we're going to look at what is, we have a power of 63, what is our actual speed, or I called it wheel speed for them, but that's the angular velocity that we're talking about. So we're going to take our line up to the curve, and we read it from there, and it looks like our angular velocity is going to be 100 revolutions per minute. Now, we're going to calculate this, or this is our calculated value, or actually our actual value, but there's going to be some things that are going to be a little different in our actual test, because these guys did this test without any resistance on the wheels. So our values are going to be maybe a little bit less. I'm expecting them to be maybe 80 to 90 revolutions per minute. But let's start with this value just to get us started. So we do want to, since we're going to be talking about in seconds, we want to, minutes are too long for us and for computers. So we're going to convert this into revolutions per second. So I just did this, and to do this, we have to just divide by 60 seconds per minute, and we get 1.67 revolutions per second. And this is also a very important number for us. So we're going to keep that, put a box around that, and keep that number. All right, so here's what we know. We know our circumference. Okay, we know our angular velocity, omega, is equal to 1.67 revolutions per second. Okay, we do know our distance traveled that we want to travel, and this is going to be capital D. And for this case, D, for our first case, actually, D is going to be 1 meter. So you're going to have to take my word for it, but this is the actual equation for time. There's a way to develop it, but I don't think it's worth it. So just take my word for it. This is actually the equation. So it's going to be D, which is, in this case, is going to be 1 meter, divided by the multiplication of our circumference and our angular velocity. So C times omega. So when I put all this in, I have 1 meter. I have 0.324 meters for my circumference times 1.67 revolutions per second. And notice that I have parentheses on the bottom. So the circumference and the angular velocity are both on the denominator. And I do the math, and I get t is equal to 1.848 seconds. Now, in programming, we don't want to deal in, at least with our wait1 msec command, we don't want to deal with seconds. We actually want to deal with milliseconds. So how do I do that? I actually multiply this number by 1000, and I'm going to get 1848 milliseconds. Now, I want you to notice something here. I didn't circle it. I was going to, but when we talk about science, the capital M actually means mega, and that's a million. So we don't really want to go there with when we write it down. So milli is actually a lowercase m, so that's why it's going to be a lowercase m secs. Now, when we do programming, we actually call it a capital M, so it's wait1 capital M sec. And that's just the way Robot C does that. It's not typical that that happens, but I just want to make you aware that I'm using lowercase m here because that's the way it should be done in science. So in where you may say, well, where did that 150 or 1850 come from? Well, here's where it is. I just rounded the 1848 to 1850 just to get us started. So let's actually get into some coding. All right, so the first thing we need to do, since this is our very first challenge, we're going to go to File in our top left corner. We're going to go to New, and then New File. Okay, once we do that, it's going to, and we're going to give it a name. So in this case, I just called it Challenge 1, Rev1 .c. The .c is actually going to be given to the program. That's going to be our extension. So when Robot C opens up a file, it knows that it's something that it can read, and the .c is the extension for that. And I want to save it in a robots1, that's what I would do, robotics1 file or folder on my desktop. That's what I would do on my computer. I'm going to let you figure out your own filing system, but it would be best if you kept all of your Robot1 stuff in one place. All right, so once we do that, we actually will get, it automatically comes in with a task main. And you can see that it says task main, and then it says has open brackets and close brackets. All the typing and all the coding that we're going to do is going to be going to happen between the two curly brackets. All right, the next thing we want to do is to go up to motors and sensor setup, and we want to select our RVW clawbot. And once we do that, it's going to insert our pragma statement. So our pragma statement should look something like this. All right, let's go. The next thing we've got to do is look at task main, or not task main. The next thing we need to do is look at our first task from our pseudocode. In this case, it said move forward 1 meter. Okay. Now I like to put comments in, so we're going to do that. So first thing I'm going to do is say, what is my first task? I'm going to move forward 1 meter. Now I have to figure out, how do I actually do that? So here we go. We're going to turn both motors on at 63 power. So here's our motor command. Okay, right motor. Okay, so we have motor, square brackets, right motor, and close square brackets is equal to 63, and again, a semicolon. So that's going to be our first command. The next thing we're going to do is motor, left motor, and it's going to be also set to 63. So that's going to be turning both of our motors on, and they're going to go to 63 power. The next thing we want to do is set the pause time to 1850 milliseconds. So here's our wait1 msec command, and it's going to be set at 1850. And notice that this is a parameter, so it's going to have our just regular parentheses, not like square brackets like the last one. Remember, motors talk through, or the motor command talks through the cortex, so that's why we need square brackets there. Okay, so we are now done with task 1. You should get yourself a little bit of applause because you just started programming. All right, so let's keep going here. Okay, the next thing we're going to look at is task 2 from our pseudocode is move backward 1 meter. And we're going to do the same thing we did in the first one. We're going to add our comment. Okay, turn both motors on at 63 power. So we're going to do both of those. And notice that we have them to go backward. All we have to do is put a negative in front of the 63. So we have right motor equals negative 63. And we did the same thing for the left motor. And just as before, we have wait1 msec 1850. So that is going to be our last one for here. Now we are done with task number 2. Now you just have 6 more to go, but if this were the end of the program, if all of our tasks were to go just forward 1 meter and back 1 meter, then we would actually be done with programming and we would then compile and download to our robot. And we could actually run this command. Now, let's look at our file right now. This is what our code looks like. And again, it only has 2 of the 8 um, tasks that we're going to do. So you have some other tasks to do, but you can just copy and paste these tasks and edit them as needed. Okay, so do want you to pay attention to all of the white space here. This is a very clean document right now. There's not a whole lot going on. We've got all kinds of white space, and the white space makes it look nice and clean. Also, I want you to realize that if I gave this to somebody like Mr. Cangelo or somebody else, they would be able to understand what's going on because I included comments. Oops, my comments disappeared. So there's my comments. So the comments are actually helping not just me, but also other people to understand what's going on. So that is a good thing to have. And in this case, you're going to be required to have comments. So make sure that you have comments in your system. All right, let's look at the report. I'm not going to do this for every challenge, but for the first challenge, I will. The reports are going to look very similar. They will change every time, but I'm just going to go through the style of the reports that you will have to do for each challenge. So the first one is going to show our point value. In this case, it's going to be 22 points. And I'll show you where the points come from in a little bit. So the first thing is going to be the objective. This is what your robot's going to do, going to need to do. Okay, in this case, go forward 1 meter. Okay, then reverse, then turn back. And okay, so it gives you pretty much not quite the pseudocode, but it gives you kind of a plan of what you have to do. Another objective that comes up later, it might just say make it through the maze. And then you're going to have to figure out all the pseudocode that you need. The next section is going to be the skills. Oops. And the next section is going to be the skills. And that is just going to tell us what skills you're going to pick up in this lesson or use in this lesson. And also, this will expand as we go. So next week, it's going to be something a little bit this plus more stuff. So every time we go through a challenge, it's going to be a little bit more difficult and more challenging. Surprise, surprise. All right, so this is where I want you to be writing your pseudocode. Okay, I have 8 spaces available because there's going to be 8 lines of tasks that we need to do. And if you decide that you need more or less, you can certainly add them or take them away. Right now, there's only 3 of them showing on page 1, but the rest of them are on page 2. So we'll see those in a second. I do want you to notice that here is where some of your points come from. So the pseudocode is worth 5 points. So make sure that you do write your pseudocode in. I give it to you on the challenge, in the presentation here. So you should be able to get those 5 points pretty easily. And you just would need to type them into the space. All right, let's look at page number 2. So here's the rest of the pseudocode. All right, the next thing I do is I show you a picture of the basketball drill course. This one you've seen in the center of the room. There's a black box with a red X in it. That's going to be your starting point, and you're going to travel the 1 meter, 2 meter, 3 meters, and 4 meters. And those marks are all on the floor in the room. Okay, so the next thing is your code. All right, so right away, I see that my code is worth 8 points. Okay, the next thing I show you is the rubric and a checklist. So I'll give you a little bit of a checklist on the left. So if you want to just put an X to make sure that you have all those things or anything, this is just to make sure you get it. So here are your points. So in this case, the pragma statement, including the pragma statement, is going to be 2 points. Using motor commands is 2 points. Using wait 1 MSEC command is worth 2 points. And as we'll see on the next page, comments are also worth 2 points. I have at least 2 points on comments in every challenge. So make sure you put your comments in there so that you can understand your code and I can understand it. Okay, let's look at page 3. There's our comments at the very top. And then this is the space that you're actually going to copy your code from Robot C and paste it in this box. So you're going to actually go to Robot C, copy it just like you normally would, and paste it in this box. That's probably going to move everything down. I think I just drew a box here. Um, so when you put something in the box, if it moves the stuff down, that's all fine. It might actually go to the next page, but that's fine. It's all going to be electronic anyway. All right. So all of that is where our 8 points are coming from, are going to be. I'm going to actually be able to edit this and make comments. You got this point, you didn't get this point, you forgot comments, I don't understand what you're doing. That kind of stuff I will comment on when I read your reports. Okay, in this case, or challenge 1 actually has some calculations. Not all of them do. So this is a section that's pretty unique to this one. There are about 3, I think, need calculations. Um, so this one does have calculations, and this section, I've just described all of the stuff that we just talked about, where the 1850 comes from. I did the math again for you, and the calculations here are worth 5 points. So let's go to page 4, and notice that here's the calculation space. There is your the equation. So it's T is equal to D divided by C omega. And that's your calculation. And then here's the space, the little table I made for you for your calculations. So when you're going 1 meter, you're going to use your weight 1 msec at, still have 1840 here, or 1848 here. You can change that to 1850. And you could do the calculations for 2 meters, 3 meters, and 4 meters, and make sure it gets in the table here. So we're doing it in seconds first, and then you're going to convert that into milliseconds. Then the last part is the physical challenge. This is what we're going to be doing in class. So once you get all your program written, you're then going to bring it to school and download it onto your robot. This particular challenge is worth 4 points. This is one of the easier ones. I think next week might be 4 points as well. But this one is going to be our physical challenge. And I'm going to, once you finish your physical challenge, I'm going to actually put a special code in this space to make sure that I see it. One of the things that I've run into in the past is students say, "Hey, Mr. F, you saw that I did the physical challenge." And I was like, no, I didn't. I have 20 some of you students, actually probably closer to 30. And I'm not going to remember who I saw finish challenge 1 or I didn't. So I'm going to, once you finish the challenge, make sure I see it, and then bring your computer over, and then I will put a special code in this section to say that I did see it. And again, that will be worth 4 points. The last thing you need to do is make sure you submit the form in Google Classroom. Couple of last thoughts. Good luck with your first challenge. Remember, your classroom time is for running your robot and troubleshooting. It is not time for starting your program. Okay, you need to take your time and do that at home during your home days. Okay, you have to use the class time to do that. So always, if you need questions or you have questions, make sure that you either email me. If you have a problem with your code, you might want to email me with your code. You might want to email me your error statements. I think I might do a general talk on error statements coming up. Or you can always visit Monday through Friday. I'm going to have a 7:15 a.m. Zoom meeting that's open. It's on Google Classroom, the link to it. So if you ever have any questions, say on a Tuesday afternoon or Tuesday, and you want to come in and check on Wednesday, I'll be there at 7:15. And Wednesdays we can talk. I have a meeting at 8:30, but we could talk for a long time on Wednesdays. So it's open every day. And I do just open it up. I leave it open for about 10 minutes. And if nobody shows up, then I close it down. So that's about all I've got for today. And again, good luck with your first challenge. Have a good day.